Hello everyone, April 30th. The crunch has not ended. Well, yesterday was able to finish the paper, written 3,500 words in 3 hours. Boom, 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 got it done. Did not proofread at all. Just put everything there. Did not have any figures. I didn't even bother to create any LaTeX for math expression. It's just words after words after words. And then got it done. Today, we have new tasks, and then that also will take some time. So we're on a crunch. Crunch, 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 crunch. But I think we'll have 2 more tasks, 2 more crunches, and then we shall be done. All right, anyway, let's go for it today. Evaluate division. Oh my, 2020.
Last year?
Yeah, last year, September 27th, a little bit before my birthday. Apparently, it's a difficult question. My first submission is 9:26 p.m. Didn't get accepted until 10:29. 1 hour. And it's also likely that I check the results, check the answer. Okay, what is this evaluate division? You're given an array of variables, equations, and an array of real numbers. Didn't ring any bell. Equations I, those values represent the equation AI divided by bi. Each AI and bi is a string that represents a single variable. Oh, I think I remember this. It's very difficult. And I think this uses union find. It's like this week is all union find. I think this is a union find. I have vague memory. You're also given some queries where queries j equals this represent the jth query, jQuery, where you must find the answer Cj divided by Dj. Return the answers to all queries. If a single answer cannot be determined, return -1. The input is always valid. You may assume that evaluating the queries will not result in division by 0, and then there is no contradiction. Hold on. So what we want to do again? So I given AB, given BC, right? So I know A divided by B is 2. B divided by C is 3. I want to find A divided by C. Well, let's just multiply. B divided by A, that's just the inverse of this. A divided by E, well, there's no E. A divided by A, there's no X. Oh, yeah, I remember this one. I used some very, it's not convoluted. I use a convoluted method, which honestly is not correct, actually. No, it is correct. It passes everything, but I don't feel like it's correct. So if this, okay. All right, so how do we solve this? Hey, hold on. We can have 2 BC divided by CD. And that just B divided by D, right? Awesome. I think it is to find a common thing. Okay. So let's take a look at this. We have A divided by B is 1.5. B divided by C is 2.5. BC divided by CD is 5.0. So A divided by B. So A and B has relation. So I can say I can group A and B together. Yes. and then B and C, I group B and C together, right? And then by doing that, I know which ones are together. That is union find. But then the next question is, who is going to be judged as 1? Who is going to be judged as 1? Let me think. So A divided by B. Let's say we make B, so arbitrarily, right? The first two, we make the division, and I will make one of them is 1, and the other is whatever value it is. And when B and C come together, we can look into that, right? So we group them together, and then C will be assigned, so they will have a value. So I need to change, I need to add something to the union find. Alright, so every time we union, we'll look into the value list and trying to see what it is. Alright, lowercase English letters and digits, which means equations only have 26 digits, right? Yeah, I think the equations are all equations and queries. They're all English letters. So in that case, I know the size. Size is 26, and then you're coming in. I'll find your ord, right? Okay, that's fine. And then I arbitrarily set one of the value. Yeah, we can set everybody to, let's say we set everybody to 0, right? Which is not right. So, oh, hold on. It could be 0. Nope. Value is larger than 0. Value cannot be 0. So, value is a larger than 0 thing. Okay. So, I can initialize all of their value to be 0. And then when I'm coming in, one of them was set to 1. Right? And if both are 0, I just set one of them to 1. If someone has a value, then we just compute whatever value it is. And then once we're done, we start, and if we check, like say x and y, and then there's no such a value, like x, we check the value is 0, then we just return -1. Anyone is 0, we return -1. 0 means we have not checked it. All right, I think we have a solution. Union find. This time is for real. Yesterday I was trying to go union find, but it turns out I don't need union find. Today this is union find. Well, thanks for solving this in the past, so giving me some idea where to start. But the good thing is we can do union find one more time. All right, I think just it's necessary. Practice makes perfect. You have to practice. You don't practice, this is not going to work. So we're going to have parent will be list range and self.rank equals 0 times n. Now you have to keep just writing this enough amount of time, then you will be able to, figure out not putting this integer, right? I mean, that's fine. Self.parent equals self.find self.parent x. So this is a path compression. And then return this def union. All right, this union is going to be different. Okay, so union is going to be different. Why? Because I forgot one more. So self.val 0 times n. Okay, so why is this different? Because if there are a union, of course, which I say no, that's not in terms of Boolean value. So if px py equals self.find x self.find y, right? We'll get py py. So if px is not equal to py, then we say if px is self.rank, right? If the rank px is larger than self.rank py, and self.parent parent y equals to px. Now if self.rank px is smaller self.rank py, in that case self.parent x equals py, else arbitrarily parent y equals px, and then self.rank px, no x, no px, okay, plus equal 1, and then return true, return false. All right, this is, but we need to add something about values. Every time on the union, right, if this, so once we're done, we're going to check the value. We say how do we say? If self.val x equal to 0 and self.val y, we can just say if not, right? If not this and this, then union, let's put another value. So what's the other value? The ratio. It's going to be a float, right? So it'll be a ratio. I mean, it's going to be x divided by y. All right, x divided by y. So now we say is x has no value, but y has value. So we say self.val x is equal to ratio times self.val y. All right, so this divided by y equals this, and then, right, if not y, but x, that is self.val y. So x divided y equals something. So that shall be self.val x divided by ratio. Else both are 0. And then we just arbitrarily set self.val y equal to 1. And self.val x equal to ratio. Yep. So that's that. That's my DSU. And then we can put this one in. Okay, so union find equal DSU 26, right? And then for x, y, v in zip equations values uf dot union. Interesting. I just forgot. Wait, is that all lowercase letters, right? Yeah. Ord, I think 65. That's a large A, 65. Small a is 97. It's fine. So we say union x is going to be x, but that's going to be ord x minus 97, ord y minus 97, and v. So once we're done, and then when the return is, say, for xy in queries, right? What is queries? So query is this times this, and we say It's this res equals this, right? R equals uf dot val x ord x minus 97 times uf. Well, it's not times, right? It's divide. Oof. Then what do we do? Well, what we do is say if this times uf dot val ord y minus 97. If not, then res dot append minus 1. Else res dot append this divided by this. And return res. Alright. Test. Equation queries. And the output. I wonder if this can handle. Wait, did you get values? I did get values. Okay. Let's test. But hold on. I'm not ready yet. Equations, values, queries. Equations, values, queries. Oh, shoot! Ah, that is correct. Oh my. I forgot of this. Oh, it's not just single ones. We have we have doubles. Ay. How do we handle doubles? I forgot. Completely forgot about the doubles. B, C, and then CD. Input is always valid. So, oof. Enjoy.
I think you mean to unlock it?
No. I think by the time you're done, I done. You shall be done.
Sure.
You know what? Unlock it. Unlock it, and then we need to keep it on. Otherwise, it will shut off again. So what do we do with this? So input. We'll have multiple, right? I'll have multiple. So we can group all of them together. It says input is always valid, right? So the equations will always be valid. What does that mean? That just means I can sort. So we put the singles in first. Okay? We put the singles in first and handle the doubles at the end. And when we handle the doubles, we shall already have. Wait, hold on. I have some questions. I have some questions I want to solve. Okay, I have some thing to resolve. What if I had said BG and CG? Will this one give us good results? Yep, it doesn't care. It does not care. Let's have a recipe website. I forgot the name of the website.
Loving and vegan.
Huh?
Loving and vegan. I love vegan.
You're good. Just pick anything. And then cook mode. Done.
How did I do that?
Must be some simple things running in the background. Oh, I'm still having trouble with this. So I need to figure out. Okay, I can turn into a set and a set, right? And then we need to remove. How do I remove the same thing? No. Hold on, let me think. So if I have multiple, right, I go one by one and I'll try to union. Or this union this. But I don't know the value. I need a value, right? I need a value. So, but first of all, okay, I turn that into a set, turn that into a set. We go one by one, and then for each one, and it says it's less than 5, right? So for each one, oh, we can do minus, hold on. This one minus this. Man, we'll have to do the cheat again. A minus B. A minus C. C minus A. So when we do this, I can B minus A. Yeah, so we can do this. Then we'll have the one that's unique. So we can get rid of the ones that's the same. Okay. Now once we do that, then we can go from each one. So let's say let's sort this thing first. Let's say equations dot sort key equals lambda tuple, right? len top 0 and then len top 1. So this one was sorted from small to big on these. So the single ones will go first. And then I'm going to say sxsy equals set x set y, and sx sy equals sx minus sy and sy minus sx. Right? And then what? And then I don't like it. Let's say list x and list y equals list this. This is removing the same thing. Now we can say if they're both 1, right? We say if len this equal to 1 and len this one equal to 1, then boom, no problem. And then it's just lx 0 and then ly 0. That's fine. If say len this is 1 and len this is larger than 1. Okay? So if that happens, then what? What if both of ly is not defined? So we do x union one of them and x union the other one, right? And when I union that, what's the value we give? Alright, I have to do this one first. And then try to think again. I know it's union fine, that's another trouble. Yeah, let's submit this, pass it, and then we can keep working on it. Okay. Wow, this is so complicated, so I actually didn't see. Okay, so now we have removed them. Okay, so we have some remaining, and then we have done those first, and it says the input is always valid. So what I'm afraid is if not everyone has been set, then you're talking about if none of them has been set, right? And if 2 multiplied together equals a value. And I say this divide this equals a value. Hmm. Why don't we do it outside? Why don't we do this one outside? All the ratio or not, let's do this outside. Okay, so now we have these x and y. So we will put them into a set and turn them into a list. Well, let's do it this way. Let's say sx, sy will equal to set, right? It's going to be 2 set. And then, let's say for L in x, if vowels ord L minus 97, right? Then V divided equal to this thing, right? We just remove this, because this divided this, so we just delete this thing. Else sx dot add x, add L. And then we do the same thing for y. Right, sy equals this. Now we do lx ly. This is fine. Now come in here. Now if it's more, well, I mean, I don't expect it to be more, but if it is still more, so if 1 and 1, right? If this is more, then I'd expect, if it could be, right? We can have this divided by this and this. Now what? We can have like set up 2 functions. Oh, if it's 2, it'll always work, right? So in union, oh, hold on. Union these 2, and then we need to update their value, right? Then why do we use union and find in the first place? Oh, man. So we union everybody, right? We union B, C, and C and D, right? We union everybody. So we union them together. And then what? And then I want a representation for each value, right? So when you union them, right? When you union them, union B, C, and C, D. Now this one is easy to solve, right? You just need to remove the C. What is hard to solve is if I have, I say AB divided by CD, right? I'll have 4 variables. We can do, A, B, and C, A, C, and B, A, B, C, and A, like this. Now we're gonna do this. You can say we're union A, B, and C, but what do we consider AB? We consider AB as an entity. If I union A, B, and C, we can set C to a value. Say C equal 1, AB equals some other value. And then I can keep union AB. Nah, that's not right. AB has to equal to some value. Right? AB has to equal to some value. C equals to some. And then we do AC and B. Well, if we do AC and B, C I set to 1, so I can say maybe from A and B equals something. Right? And then finally we have B and A. What does union find help us? So when A and B union together, and then we go B and C union together, they immediately C can be connected to A. That's what we want, right? That's what we want. And then the connection, right? In the connection, now it says that the valid input is always valid, right? That means everybody shall be grouped together. Everyone will have a link together. So what does that mean? So when we do the union, right? If A union B, and then we arbitrarily they will go pointing. So we're setting A as the base, okay? So if we set A union B, we set everyone's looking into A. So the parent, we're saying the parent, but it has to be a x divided by y, I have a ratio, right? We find a parent, and then we set a parent, okay? Now, after we do that, they have the same parent, okay? They have the same parent. And then, what we need to see is the parent's value. Because everybody is connecting back to the parent, right? So, hold on, but they all have the same parent. Okay, they all have the same parent, just how much of that parent? And we can just, say the parent represents 1, right? Then no, I'm confused. Now we union A and B, okay? And then I say arbitrarily I set B to 1, A has a value. Now A and B has a value. Then I union B and C, right? I union B and C. And then when I union B and C, then they are also connected to A. Or, what happens not B and C, to A and C. But then we don't need union, right? A and B I already set the value. And then if we do A and C, then I can just check what A's value is, and we can set C. But what's the benefit of using union find? The benefit should be when I do this, automatically I get connected to A, right? That's why we use union find. Within B and C, we union B and C together, and then they will all point into A. So now, and then if we look for the parent of B, we'll go to A. Parent of C will also go to A. Well, B has a value. I don't understand. How do you use union find? What's the benefit of using union find? If I union the two, I know they belong to the same group, but everybody will belong to the same group. Like there's no need for doing that. But I think it helps, like say, it helps with A and B, C and D, right? So A and B, I have some value. C and D, I have some. Now I do A and C, right? if we have like some value, I don't know, just random value. We'll do A and C. Let's say some value. So when we do this, everybody's value needs to be shifted. Like this is 3. Let's say, okay, if it is 3, it should be 12, right? And this will be 12, and this should be 6. Like we need to do this type of thing. That's the benefit of union find. How do we handle that? I have no idea. I know it's union find, but I don't know how to apply it. Alright, it's getting ridiculous. Heinous union find. A graph. Okay, it's a graph problem. Union find is a graph, right? But let's rethink in terms of graph. A, B, let's say the edge is 2. B, C, edge is 3. Okay? So what we're looking for is A divided by C. So from A to B, B to C. So that's this times this, right? This path times this path. How about B to A? B to A go the other way, so that's 0.5. How about E? E is not in it. A to A, oh, that's always going to be 1 because you're going to yourself. Okay, so now A to B is equal to 1.5. B to C is equal to 2.5. Well, how do I represent BC to CD? What's BC to CD? Okay, we can just divide this to say B divided by C times C divided by D. How about that? And for BC and CD, or BD and C divided by C. So that's going to be BC and then times C to D. Okay, so BC, CD. BC I know is 2.5. CD I don't know, but the result is 5. So C to D must be 2. Right? Now, I want to find A to C. So we put 1.5 times 2.5. Right? Okay. How about A to C? C to B. Now, C to B is reverse, so that's 0.4. BC to CD. BC to CD. We're done. How about CD to BC? So CD, so I have C to B. So we're going to do C to B and D to C. C to B is 1 over 2.5. D to C is 1 over 2. So 1 divided by 2.5, that's 1 divided by 2. 0.2. This looks promising. And it's not union find. This is not union find. This is pure graph. And it's we can make it bidirectional, so we just put different values into it. What do we have? Let's say AB divided by C. Oh, then just A to C and then to B times B to B. No. How do you do that? Because you have to divide by something. B to 1. B to 1. So we have a special one called 1. Yeah, let's say AB divided by C. We can just say A to C times B to 1. So we say A to C, right, times B to value 1 equals some value. Oh, they don't need to connect. It's not a hint. If you look at it, then you're checking your results. But I have no idea. Like, how do we use union and find? Go slowly. Modify values of each union node along the way. How are you sure U1 and U2 always have a value? Treat U2 as the new parent. Point everything to U2. Okay, we got a ratio. So when we union the two, so we have this value, right? So when we union the two values, okay? When we union the two values, what happens? I arbitrarily set this value, okay? Change your parent, everybody pointing to hold on, I think I might get it. So what you're saying is if we with these two, new union, right? When we do new union, we need to go through the entire thing. Anybody that's in the same union, they will be pointing to the same value. So whatever this value is, well, they are relative to the previous parent, right? So we find their parent. Hold on. Let's stop looking at it. So I think I got this hint from is when we get two nodes coming in, right? They all have one of them have some parent. And then I say I always treat the second one as the new parent. Okay? Then the second one's value will become the base value. Okay? So the second one's value is the base value. Alright? That's fine. And then if the second value is the base value, no, it should be, hold on. If the two are already in the union find, then we don't have to do anything, right? They shall already be handled. It's only after the two are not. So we find the one that's not inside the union find yet, right? We find the one that's not inside, and then we set that one's value to be, whatever value, and then everybody that's already in the union, we're going to loop through them, so they shall all have a value that's relative to their parent, right? They'll have a value relative to their parent. But now we have a new parent, and then we have a ratio. So everyone, whatever value they have, right? Now we need to find their parent. Yes, we find a parent, get the parent's value, and wait, hold on. One more time. Do it again. So we have two values coming in, right? And if they are already in the union, we let them go. If they're not in the union, then we arbitrarily choose one value as the new parent. Okay, we choose one value as the new parent. And then the other value already has a parent. And other node has a value, which is associated with the parent. Okay, so in this case, this value I need to compute, and then this value has a ratio towards the new parent, right? So we have this ratio. So then we need to compute a new ratio, right? We need to compute a new ratio so that we can change the value of the original parent. Right, so let's say this, if I have 3 times the original parent, but now the value is 2. So what does my value change into? My value should change into 2, which means it's 2 over 3, right? So that's the new ratio. So everybody goes in, need to multiply by this value. So that will be relative to the new value. Okay. So that's okay. I see how union find goes into this. That's fine. Yeah, that I can stand behind. But now I have a new problem. But not a new problem, still the old problem. How do we handle this? Right? How do we handle this? I have 2 letters. How do we handle 2 letters? 2 letters. Oh. Two letters. I mean, I was thinking about this. I can just do like B over C and C over D. Well, I mean, well, they say it's always valid. I can just, think that it's always valid. That whenever we hit this situation, some majority of these values will be set. But it is definitely possible. Like I can think, right? You can put some together because that's just unknown variables. And then we have 3 unknown variables. We can set up 3 functions, and we shall be able to solve this. Are you saying like we consider? I don't know. I don't have a good result. I don't have a good idea for this. All right, let's go back to the hints. So I kind of know original. Yeah, I'm actually looking at the results. What the hell is this? What the hell is this? I have the union x1, x2, got the value. Huh. What is this? What's a union map? Union map is a dictionary. And I say if both are not in, I set them, and I set union map x1 value to value, and one parent will equal to this. That's alright. And this will be 1. That's fine. That's fine. This is just say if both have not been put in together. Wait. I did not have to handle them together. Like I didn't check if this is 1 letter or 2 letters. Huh? What? Wait. I mean, read the question again. Equations, is a string that represents a single variable. Oh my god. A or B is a string that represents a single variable. So, I think this is a single variable. It does not mean B times C. You gotta be kidding me. It does not mean B times C. That's why here is BC, and here is BC as well. Represents a single variable. Oh my god. So we don't have to worry about that. Yo, you gotta be kidding me. Okay, that's fine. That's fine, but we still need the hint, right? Okay, so we don't have to worry about like it can be 3, right? That's what it means. I can be like I want to test this. Right? And then let's say B and C. B and C. Well, according to the current question, it should not be possible. I don't know. Is it be possible? Oh shoot! I need to return something. Yeah. It says -1, but if this, well, I can like cancel the G. Now BA divided by C. Now I know A divided by B. Actually, A divided by B. Actually, it's not a good example. How about? Yeah, that's not a good example. You know what? Let's not worry about it. Let's just think that each one is a single value. Okay, I just think each one is a single value. It says A or B is a string that represents a single variable. A single variable. So this BC is a single variable. So when that is the case, then my DSU shall not be this. Right? I need to. This need to be a dictionary. This is a dictionary as well. I don't need to pass in anything. And then this can be a str. and this is going to be a str as well. And now if x is not equal to, this is fine, this is equal to fine, and I'll return okay. And these are all strs. Str, this is going to be str. This is still going to be this. I want to find the parents. If the parents are not the same, well, I mean, let's not do this. So we said, right? If the parents are not the same. Oh, hold on. The parents are not the same. We can't just say this shall the part dot get x and x. I will try to get it. If we don't get it, I'll get it myself. Right? And this is also dot get. We're gonna get x and then x, which just means, and I'll find x, which is just x itself. You know what? No. If x not in self.parent, which means I have not do anything, then we set it to x. Then I don't have to get. This is going to be this. Right? If x is not in it, we set it. And if it's not equal to, well, now it will be equal to, right? And now I just return this. That's fine. And now we can find the parent of these two. And the idea is the parent will always be the same, right? That's the key. Okay. So find is still finding the parent, and then in union, I want everyone to point into the new parent. That's fine. So union, I just say if they're not the same. If they're the same, we don't change anything. We say already figure it out. So if they're not the same, okay, if they're not the same, then I arbitrarily pick y, okay? I pick y to be, so we say arbitrarily pick y to be the new parent. So now what? So if y is the new parent, okay, so now y is the new parent, and I need to set y's value to 1. So we need a val, so self.val, okay? So we arbitrarily set y. No, it has to be, hold on. If they're not the same, right? If they're not the same, what if self.val y has a value? If it has a value, then I need to change it, right? I need to change it. So I can change it by setting to 1. Hold on. Let me see. Then if y has a value, now I need to set it to 1. But this y is connected to something else. Right? It's if y has a value and x does not have value. If y has a value, then I can find y's parent. Right? Py is y's parent. py is y's parent. Still got stuck. Yeah, we'll find the parents, and the parents are not the same. And we say if the parents are the same, so they're all pointing to the same guy, and I say it's all been done. If the parents are not the same, so py is pointing to something, px points to something else, and then I shall find them. So if they're not the same, okay, if they're not the same, the parents are not the same, then I shall go through everything inside this, and then for each one has the same parent as px, right? Then they'll all change to py, and then their ratio will also be changed. Okay? So we say for node and a parent in self.parent the items, right? Because we want all pointed to py. We can set the default value to 1. Right? So parent dot items. And then we say if parent is equal to px, then self.parent node equals py, self.val node times equal to hold on. That's the parent, so everybody's pointing to this. I want everybody to point to this. So if there's 2 times of this, now x is equal to that much y. I say x divided by y equals a. X equals b times px. Y equals c times py. Right? Now we want everybody to point to because x equals a times y. Right? Now that's so b times px c times py equals a. So now px shall equal to a times c times py divided by b. Or we say because x equals b times px, right? So px is equal to this thing. Then everybody is something times px, something times this. Okay, so I have px and py is equal to this. Then we say the collections. Okay, so I don't need rank. Val can be default dict. and 1. Okay, then that's that. Then we say self.val x, self.val x, self.val x, no, self.val px, okay, self.val px times self.val x. That doesn't make any sense. No, it doesn't make any sense. Let's say the previous, that's going to be 1, right? So it's going to be, oh my god. Let's just do int. Okay. Then we find their parents. If the parents is 0, then we set them to, well, they will always have parent because we do fine, so the parent could just be themselves. Right? The parent could just be themselves. If the parent is themselves, then say if parent is if px is equal to x and py is equal to y, right? So parents are themselves. If parents are themselves, then I simply say if the parents, if this one's parent is itself, that one's parent is itself, so I can just arbitrarily choose one of them, right? Then we can just say self.val y equal 1, self.val x equals ratio, and self.parent x equal to y, equal to py. Yeah. Equal to y, it's the same. Okay. Elif, if px is equal to, no, px is not equal to x, and py is equal to y. So y is a newcomer. Px is not. Px has a parent, and by definition, the parent's value is going to be 1, right? So now I say self.val y. I set this to 1. Okay. Now I have to go through every single thing. Now self.x, val x has a certain value, right? It has a certain value, but since I set y to 1, x divided by y equals this, so x has a value, right? Which means everyone need to do that. So as a ratio, I don't like this ratio. Let's call it q. Okay, now here I can call ratio shall equal to, because this should be equal to this one, but not this one, so it has to be q divided by self.val x, right? Q divided by self.val x. And then I say for node parent in this, if parent equals this, parent node equal to y, right? And val node times equal to ratio. So that's that. L if px is equal to x and py is not equal to y. So this situation is py has already been part of it, but px is new. Well, in that case, first of all, self dot parent x shall equal to py, parent y, right? That shall equal to parent y. Then what? That equal to parent y. Self dot value x shall equal to self dot value y times q. Okay. Else, if they're both not the same, then it's guaranteed that they all point into the same parent. So I just say, in that case, we just don't do anything. And I don't have to return anything. So in this case, now we don't have to do any of these. We just go ahead, DSU is this, and then I simply just do this, x and y, and a v. Okay? And then we're going to go through the query. Say if not, this x and y, otherwise x divided by y. We have some value. We have some value, but it's not correct. Hold on, I'll be back. Man, this problem is so tough. I remember last time it took me a long time to solve, and today it still took me a long time to solve. And I still haven't solved it. Even after I read the solution, I'm still confused. Okay, let's see. Why is it wrong? I think I got the first one. First one's wrong. Okay. So say A, B is 2, right? And then A, B, and 2, that should be A and B. And then they're both the same, so I say a value of y equals 1. So B becomes 1. A becomes 2. Okay? And then parent A equals y. Okay? That's fine. And then probably should, let's print something out. Let's print self.parent self.val. Okay, so that's not correct. Oh, equal to. Okay, so now it's A, B, here, and now next one is B and C. All right, B and C. So I'll find B, right? So B is in this, and B is also equal to B itself. That's fine. And then C is not in it. Okay, C is not in it. Then both are the same. If Py is equal to Y, so Y is a new thing, and then Px is not. So I always set Y. What if there's no X in it? Yeah, that's why we have an issue. Let's say if Py equal to Y, so we know Y is the root. We always set this to this, right? Then we check. If not, self.val x, then we don't need to use this. We can use, yeah, that's fine. If not this, then we set it to this, right? Wow, awesome. If not, we set it to this. A ratio. How about if not, I set it to 1, okay? And then I set the ratio. And then for every single one, so node and parent in this, if parent is equal to px, yes, if parent equal to px, then parent should be y, and value should times equals this. And then this one I can just say if it's else, okay? And then if it's else, x parent is py, value equal to y value times q. Y value times q. Okay, this one seemed to work. Let's try the other two. Okay, This seems to work. So let me go through this whole logic again. So find, so this has become this, right? So we'll say find, and then union. We find their parents. If py is equal to y, that means y is a root already. So y is root parent. Y is parent. Y is parent already. Then everything else looks up to y. Okay, so we set y to 1, and we say if not x, and we set x to 1. Actually, you can just say divided this if self.val x else 1. You can do this, right? So we get a ratio. And then for everyone, if your parent is equal to px, so it could be the old parent, then we reset everything to y, and we reset your value. Else, if py is not equal to y, which means y is not a parent, so somebody else is the parent, then we're pointing x to that parent, right? Because this basically means it doesn't matter. X could be equal to y, then we also they could be equal, then we point to y. If they're not equal, then screw you. I'm gonna also point to py. So in that case, they're gonna be point, and my value is also gonna change, become self.value y. Now self.value y is not gonna be 0. Why? Because py is not equal to y, right? So I'm pointing to something. Once I point to something, it's not going to be 0. So we have this. So it's a modified union find, right? Modified union find. I'm just about to say something. What the hell? No, it is not correct. What? Wait. How? This is ridiculous. I point to C. A is 0. Ooh, what the? I never checked. I never said A. How is A remains 0? I don't understand. If py is equal to y, yeah. So b set to 1, yeah. And then I go through. A shall be equal to A, right? The hell? Yeah, it's A. See, that's A. Which means px must be A. Px, yeah. I updated. What the hell? How is A go back to 0? Px is A, parent is A, right? Hold on. Let's check this. Node parent Px Py. Node parent Px, right? So Px equal to Py. What's the ratio? Ratio is 2. Oh, wow, I see. Default is this. But I need that. Alright, screw that. Screw that. I'm setting 1. I'm setting 1. Then I can just directly do this. I don't have to do any of this. Yeah, we still need to set. And then this is fine. And these are all fine. These are all fine. So only thing to change is here. Say if x not in, right, or y not in, then we do this. Otherwise we do this. There we go. So default dict. Well, I mean, for one thing, this will be an easier solution than the previous one, I believe. Ah, jeez. Nope. Not there yet. The heck? I got wrong on the first 2 values. Oh, I thought we'd done. I got wrong in BA. Huh? AB, EF, and B, and BE. Parent, self. Yeah, it's not right. A to B, B to B, E to F, F to F. That's fine. The last one, B and E. So after the last one, B and E. A, B, E, F, B, E, F, H are all associated. Okay, so something is wrong. Right, something is wrong. Alright, so P, and then last one is BF. No, last one is BE, right? So BE goes in. BE goes in, and now we find B is to B, E is to F, because E is to F. So B and F. Okay, so B and F. PX is B, and then B and F. And then PY is F, and F is equal to F. So I set that to 1, that's fine. And now we say ratio is Q divided by current value. And we say everybody whose parent equal to B, and it should be Y. YA is still pointing to B. Node parent. Oh, B and E. Wait. B and E. Hold on. Hold on. I think it should be like this. Ratio, right? Should always be the current value. If PY equal to Y, which means Y is a new one, is set to 1. Otherwise, I always do. So I always try to hit Y. Now the idea is Y is always going to be 1 if it's the root. And then, because I set to 1, so this will always be 1. Right? So always going to be PY's value times Q divided by this X value. That's the ratio. Yeah? Yeah, that's the ratio. And then, for everything in it, they should all equal to PY and no time ratio. I think this is right. I just need to change. Use math. Wait, it's not close? What? Huh. Of course not. I think that's one's tolerance. Oops. Oops. I don't know. What's the tolerance? RELTO. There you go. Sorry, we modify the tolerance. Alright, so now it's much simpler. Okay. So now we have a good case. We have a good case. I'm going to have to speak tomorrow. Let's keep working on it. Alright, I'm back. So I think this is right. This is apparently right. So the change is in the union, right? So we just need to find a ratio. Basically what we're saying is, we do this, px, py, we always say py is the root, right? We want py to be the root. So we need to calculate the ratio. So the ratio is for the current value, y and x, right? So we say for the ratio, the new x value shall be the current y value times the q, right, which is the quotient between the two. And then for everything who has the same parent as this, so yeah, we're going to arbitrarily force all values, all nodes in union find to point to py as their new parent. That's what I want to do. So if this, and then we just point everything, and then we also update everyone's value as well according to the new ratio. Okay, so this one I have confidence. I mean, although we did check the results, but this is much simpler than before. Oh, jeez. Come on, man. What the heck? They had to have the same parent. Okay, I see. I see what's the issue. That's fine. That is fine. That is totally fine. It's just a simple change. Simple change shall do. No worry. Man, this one, you need to put this one as your nightmare, man. This is nightmare. Okay, so what we do is, it's not checking this. If uf.find is not equal to uf.find, they must y be of the same parent. What? The hell? Oh, not only that, they need to also be, oh, jeez. I need both. If x is not in uf.val, right? And or y not in uf.val, or the parents are not the same. There we go. That's the thing. All right, come on. Come on now. Oh man, this is... I don't know what to say. Don't know what to say. Like, I know it's union find, but still wasn't able to. 399. Very tough problem. It was very tough the last time and equally tough this time. In fact, it is even worse this time, because last time, at least, I solved it, albeit using a convoluted solution. This time, I knew the solution must be union fine, but still I couldn't figure out how. I mean, fortunately, by such struggle, I was able to drastically improve the union find code compared to a year ago. The idea is simple. We create a custom union find, right, where the parent array becomes a dict because the input nodes are no longer integers but string. Also, we can do away with the rank array because we will arbitrarily always pick the second node in the union operation, pick the parent of the second node in the union operation as the parent. Now the key is to keep another dictionary that stores the values of each node, given that the current the current parents have value 1. Now this requires computing a ratio that each value that is already in each value that is already in the union, each value is already union and has the same parent as the first node in the union operation, computes ratio. Each node that is already in the union has the same parent must multiply in order to modify its value. And when computing the output, we have to check whether the query nodes are in union find, and if they are in union find, whether they have same parent. Both are important. Let's just say the latter check is crucial because only nodes that share the same parent can have their values divided. Tough problem. Very tough. So, 2 hours. I mean, it's good. It's always good to revisit these problems. But somehow it's just what it feels to me is the tough problem is always going to be tough for me. And maybe if I am more fresh, I'll be able to figure out. I mean, if you look at now, this part is easy, right? This part is not hard. The hard is to modify this, and then it took a lot of efforts. Yeah, I mean, this week the performance has been very poor this week. I guess it's just because the crunch, we crunch every day, and it's still not over. We still have one more day to crunch. So I'll see you guys tomorrow for more crunch. Adios.